I mean, a video of me, or is it just the still profile?
Just the
profile.
picture.
Just that profile tonight. Dang.
Yeah.
Oh, well. My hair looks a lot better there than it does when I haven't started. I didn't get to the hairdresser yet, so.
That's funny. All right, so let's just dive right into this.
And before we start, hey, you guys, you know how to delete videos, right? After we're all done the class, that we can just delete the videos, and that's what I do with them after. I clean them up so they're not hanging around YouTube.
Yep.
That's a good idea. Oh, that is a good idea.
Yep. All right, so I say we do the same thing we did last time. Just go in order. Erin, you're first, then Kelsey.
Okay.
And Linda.
And where do you want to start?
That way.
Just
we
with
start with part 2, right?
Yeah. I didn't, once I got past that one thing, I didn't have any more questions.
Me too.
Okay. Go ahead, Erin.
Okay. All right, so the first one on part 2?
Yeah.
Okay, let me just scroll to it here. Okay. Okay, what are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? And they're just in the book. A simple random sample was drawn from the population. And then number 2, X bar is normally distributed. And then 3, the standard deviation is assumed to be known. Do you guys have that?
Yeah.
Okay.
Yep.
Okay, good.
I liked what he said in the video that on number 2 that you can test that with the central limit theorem or a QQ plot, and that number 3 tells us we'll be doing a z-score because the standard deviation is known.
Yep. All right, Kelsey.
Okay.
What did you get for 7?
I got 541. So,
everyone agree?
Yep. Yeah. Yep, I got that.
Do you have trouble with the terminology on that one, Erin?
For for what? Sorry.
While we were waiting for you, we were talking
Number
about
7
terminology on that one, about the difference between the sample mean and the population mean and why we're using it.
Oh, yes. Sometimes I think I kind of had a little bit of a hard time. I don't know what do you guys think the difference is? The mean difference.
Well, on the video, what got me going on that and fixed it for me is on the video that we're using the sample mean from our study to estimate the larger population mean. And remember in the it told us.
That's right. Okay.
That we use the sample mean. We were talking about how you just pick numbers out of thin air.
Okay. Number 8. Linda.
Okay. Create a 95% confidence interval for the population mean. Show all your work below. I put mine into the sheet that Erin conveniently sent. But then I felt guilty.
What'd you get, though?
I felt guilty, and I went and I calculated it by hand and got it wrong that way. But, and I'm going to go back and figure out why I got it wrong. Anyway, it's the formula X bar plus the time multiplying the standard deviation sigma by the square root of our sample size n. So you plug the numbers into the formula. 541 is the X bar, it's the sample mean, and the population mean in this case. And then our z-score, we get that by putting 0.95 into the applet.
Yeah.
And that has a 0.5 level of confidence, right? I think. And then that gives us, that's that standard 1.96. So we have 541 minus 1.96. And then our sigma is 32. The standard deviation is 32. And the sample size is 50. So we get the square root of the sample size. And when we calculate that out, you get 532.13 and 549.87.
Wait, what was the first one?
532. 532.13.
Yeah.
And 549.87.
That's right. That's what I got.
Yeah, me too. Yep.
All right. So for number 9, the only difference was the sample size. Instead of 50, you plug in 100. So I got 534.728 and 547.272. I didn't know how far out the decimal should be, so I just did 3.
Yeah,
That's what I did too.
Yeah. I did 3, so I got what you got. So
Awesome.
Yeah, same here. I got the same thing.
All right, Erin, 10.
All right. How does the margin of error for the 95% confidence interval of the sample size 50 compare with the margin of error for the 95% confidence interval of the sample size of 100? And the margin of error is just the z-score times standard deviation divided by the square root of n.
right.
And so you just use that part. And so the margin of error gets smaller as the sample size gets larger.
Yeah. So the range between the numbers gets narrowed down.
Yeah. That's kind of how I understood it. So.
Yep. Awesome.
Cool.
All right, Kelsey, 11.
okay, create a 98% confidence interval for the original 50 students. So I just did that same formula and got 533.556, and then the other one was 548.444.
That's right. That's what I got.
Me too.
Yeah, we just had to get a new z-score on that one to change that.
Yeah.
Yeah.
The
Yep.
1.645 is the z-score. That.
Yep.
Yeah, that's what I got too. So.
Awesome. All right, Linda, 12.
Damn. Making myself a note. Okay, how does the margin of error for the 95% confidence interval that you computed in question 8 compare to the margin of error for the 90% confidence interval that you computed in question 11? All we're doing is comparing them and noticing that as the numbers go narrower, as they get as we change from 95 to 90, then the margin of error gets smaller as the sample size gets bigger. So when you have 95%, when you switch it to less, to 90%, the margin of error gets smaller, and then the level of confidence gets smaller too, right?
Yeah. I put when the margin of error gets smaller, the range gets smaller.
That makes sense.
Yep.
All right, number 13. I got, so we're solving for n this time.
Yep.
And it's n times z, or n equals z times, what is this, standard deviation divided by the m, and that's all raised to the square. And I got 157.3. Or 158, I guess is what we're supposed to say.
Yeah, you have to get the whole
When I watched the video.
Yeah, you got to round it. So.
You had to round it. So.
Right.
158. Awesome. Any questions?
I don't think so. Not for me.
All right, I say let's jump into it.
It's a good idea.
Get it done.
Let's see how fast
I'm
we can
hoping
get
to
this
go to
done.
bed early tonight.
Yeah, I'm tired.
Let's do it, guys.
All right, starting the quiz. It's only 14 questions.
Yeah.
Says,
Oh,
I like
sweet.
ones that are
Hopefully
only
they're not too hard.
And the first 2 are easy, always.
less than 10. I thought I better check, make sure I'm opening the right group quiz here. I don't know. I've had that.
Right?
I don't know.
All
There's
right.
days when it all goes that way, downhill.
So we're going to just keep going in our order. Erin,
Am I first
Question
then?
3.
All right. I'm just waiting for my thing to load. It's almost up.
Yeah, you're good.
My computer's just being slow today. I don't know what's wrong with it.
I don't know. I'm
It's being
surprised
really
mine's
slow.
not slower with the storm going on.
Oh, yeah.
My school looked like, where I work, it looked like it was going to flood. It was raining pretty good.
Really.
Yeah.
And
It was pretty.
it was going back and forth between rain and sleet today.
It was raining pretty hard.
Nasty.
Yeah. Okay. All right. Cool. All right. Let's see. Question 3. For the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25. Oh yeah, find the margin of error. So we have to use the margin of error formula.
Yeah.
Gosh, I gotta get my pencil. Ah, there we go.
Did you email us that Excel spreadsheet?
Yeah, it's let's see. Yeah, I did. It's for that bigger formula.
Yeah.
I didn't have the margin of error formula, but
Oh, okay.
it's just the when you've got the, well, let's see. Find the margin of error for confidence. So we're just using that smaller formula, right? The m equals z. Oh, okay.
Yeah,
Okay.
the N equals.
Yeah, so that one I don't have, but I have the bigger one.
That's fine. I've got to find. I don't know what I did with my notebook.
90 is what again?
Let
Is
me
it
see.
Is it 1.96 or no? It's
Hold on, I got it.
645.
It's let's
90
see.
is 1.645.
Yeah.
For 90?
Yeah, 1.645.
Okay. Okay, that's right. Standard deviation is 50 divided by n equals 25. Okay.
Deviation. 50.
I get everything stacked here on my desktop till I don't know where anything is.
Yeah, me either.
Okay.
Okay, what are we doing again? Let me see. Find this. Okay, lesson group quiz. And the standard deviation is 50 and n is 25.
I got 16.45.
Yeah, I think that's not the right formula. That's what I got too, but I don't know if that's right.
Well, I got the same thing, so.
What's our standard deviation again?
50.
50?
Yeah, 50. And our N is 25.
Yeah, I got
I got
16.45.
10 for that. The 50 divided by the square root of 25 is 10.
Yeah, maybe it is
Yeah.
right. 16.5.
I got it. That's what I got is 10.
16.45.
16.5, yeah. Oh, well, 45, yeah.
Because it's 3. It said round out to 3 decimals.
I need to. Okay.
Yeah, and
But I didn't
unless
get 3
there's
decimals.
not a third, I didn't get a 3 decimal either.
So are we just putting 16.45?
Yeah.
Okay.
Hey, if we all got it, then, you know.
Yeah,
Yeah.
maybe.
Unless we're all doing it wrong.
No, I'm pretty sure that's the formula, isn't it?
It is.
I would think so. That's what it
Yeah.
says in our notes.
That's what I
Or-
got, 16.45.
All right,
Okay.
Kelsey.
Oh, yeah, you're
Before.
right. Which of the following statements is true? I think it's I can never remember their names, but the U-looking one with the X bar. Is that right?
Oh, mu.
That's the mean.
The one that looks
Mu.
kind of like a mu is called
Yeah.
mu, mu.
Mu is a point X estimator of X bar.
I
Okay.
have no idea. Which of the following statements is true?
Ah,
I'm not sure.
Let me go back to the book.
X bar is a point estimator for you, I believe.
that's what I think. I think, yeah, you had it backward.
Oh, yeah, I'm sorry.
Yeah, I think it's
Number
number
two?
2.
Okay, yeah.
Is that right?
Yeah.
Find that in our notes. Let's make sure that we're talking about the right thing.
Yeah.
Okay.
Yeah, because X bar is the sample statistic that estimates for the population parameter, right?
Yeah. Yeah, think about the mean. If mu is unknown, how do we know if x bar is close to it? Let's see.
So you
Short
guys
answer
put the second one on that one? Is that
for
what you
sure
did?
is x bar is close to mu.
On question 4, did you guys put the second one? X bar is the point estimator of mu?
Yes.
Yeah, that's what
Yeah,
I
that's
did.
what we put.
Isn't that what it is?
Yeah, I think so. I was just
Okay.
checking.
Yeah, that's it. Okay. All right, Linda, you're up.
Question 5.
Yeah.
Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation. It's 113. She collects a simple random sample of size 64 and computes X bar is 526. What is the point estimate for the true GMAT score? So is it like the other one where it's X bar 526?
This is the big one, isn't it?
I think so. Well, I think the next one is. I don't know.
What'd you say, Kel?
Are you talking about for?
Is it not the long problem? The bigger problem?
Isn't that for number 6? Number 6
No.
though?
Number 6 is the long problem.
Yeah, that's
The
what I
point
thought.
estimate, isn't
So-
that finding m?
Oh, yeah, that's X bar. So it's 526, right?
That's what I think.
Yeah,
What it would be.
that's what I think too.
Yeah, sorry, I was reading ahead and didn't get my
What is it?
questions right.
Oh, it's okay.
526, right?
That's what I think.
I think, yeah.
526.
Yeah, that's what I.
Okay. So now we do the long one.
Mhm, yeah.
So we're going to get the margin of error for the 95%, and that's the 1 point. Oh,
I just had it too.
Is it 1.96?
1.96.
1.9.
Yeah, 1.96.
Yep.
Okay.
That is correct.
All right.
Okay.
All right. Let's see. M
So-
is
So we
what,
separate them by commas?
Yeah, we do.
Okay.
Oh, really?
Yeah, because you're getting 2 numbers.
We don't have to put parentheses, do we?
No,
No, I just
comma.
really,
On this one, we're just getting the margin of error, right?
Yeah.
That's okay. Okay.
that's 2 numbers, right?
Yeah.
That's okay. Oh, wait, it says, what is the lower limit of this confidence interval? Question 7. Question 8 says, what's the upper limit of this confidence
Right.
interval?
This is a different.
Oh.
Wait,
Yeah.
This is the margin of error that will go either side, right?
Yeah, that's a percentage or like a decimal.
So shouldn't it be 27.685?
What?
27.685.
How'd
How
you
did
get
you-
that?
So we're just finding the margin of error for question 6, right? That's all we're doing.
So are you
Okay.
Oh.
m equals the z with a little asterisk by it, you know. And then sigma is 113, right?
50. Is that
Wait.
standard deviation
Equals
over square root
1.6.
64? So we're just finding the margin of error, so it's the smaller formula, right? Okay.
Yeah.
1 point.
Okay. I was overzealous about the big one.
Yeah, me too.
I know. I'm like, I got the spreadsheet. I want to plug it all in.
Yeah, me too.
I
All right, let's see.
What? Is that right? 13 divided by the square root of 60.
Did you guys get number 6 then, or are
What'd
you
you
guys
get?
still? I got 27.685.
That's what I
Okay.
got.
Oh, okay. All right. I'm not the only one then. So are we
Yeah.
rounding to 3 decimal places?
Yes.
Hang on. I didn't get that.
Oh, what'd you get?
I'm not sure.
Oh,
What
So-
formula did you guys use? What did you use, Erin?
I used
Oh,
the margin
okay.
of
That
error
looks
formula
better.
for number 6. So it's m equals the z-score times the standard deviation divided by the square root of n. That's the margin of error formula that we're using for number 6.
Okay. 27.69 or 27.685.
Yeah,
Yeah.
685.
Yeah. So okay, because we're rounding 3 decimal places, right?
Okay, I got it.
Okay. Okay, so the next one we can
Can we finally use
do
the
the
big
bigger
one?
one.
Yes.
Okay. Now I will
Did you guys-
continue.
Did you guys get number 7 and 8 then?
Nope. I don't
Okay.
have the cheat sheet.
Oh, I emailed it to you.
I haven't been able to get it yet.
Oh,
So
okay.
I'm just long-handing
Okay.
it.
No, that's fine. I just gave it to you guys because I thought it would be faster.
No, I love that.
So-
I just didn't have a chance to get it yet.
no, that's fine.
And the square root of 64. Are you all waiting for me?
No, I'm calculating.
Okay, good. Wait.
I don't think I entered something right. Okay, Erin, in your
Yeah?
sheet, you're using 52 as X, right?
Or 526? 526?
Ugh,
Oh,
I can't even write.
526.
I didn't even write it down right. I transferred it to my sheet.
Aaron, what did you get for the
I mean,
minus?
526 for the mean.
Okay,
Is
that's better.
that right? Did you guys get that?
Wait.
I don't know.
I'm
What one
writing.
did you, wait, what?
Okay.
Oh, for
I
for
wrote it
X.
down wrong. That's the problem here. I'm just like totally like.
Huh?
I'm just saying that I put 526 for X.
I'm in the middle of. Okay,
Is that what you guys put?
I know. I was,
Yeah,
Yeah,
I
I
put that.
I
I
know.
copied
Dang.
down.
Okay.
Okay, wait.
I put
Sheet where I
two
keep
for some
notes,
reason.
and for some reason I copied it down as 52 instead of as 526.
Oh,
I thought
you
the
missed your
lower
number.
one.
Oh, that's okay.
I thought the lower one was 498.315.
It is.
Yeah, I
That's what I
plugged
got.
in the wrong one too, Linda. I put 562.
I don't know how I do things like that. Gee.
Okay, so it's 498.315 for the lower.
Yeah.
Yes.
That's what I have.
I'm checking that laundry basket down. There's a bunch of whites in it. I can. Okay.
5. Okay.
And that would be number 7,
Okay.
right? 498.
What is
Yeah.
the lower limit of this confidence interval?
Okay. And then I do 5, 2, 6 plus 27.685. I got 553.685.
Yeah, that's what I got.
I have as well.
Baby girl. Did you find one?
6,
Find it?
5. All right.
All right. Are you guys on number 9 then?
Yeah. Who's next? Is it my turn yet? Or is it Linda?
I think I have no idea. Go ahead.
I'll do it. What would happen to the width of the confidence interval if Gina increased the sample size? What happened to the width? It would decrease, right?
That's what I think.
I never have any idea. I have to go look.
I can't remember. I need to look too.
Because if the sample size increases,
You're probably right.
then the distance between the numbers decrease. And isn't that what they're talking about?
I think so,
Let's
yeah.
see. What
What's it
happens
asking us?
with the confidence interval? Can increase the sample size?
What
So
would
as the
happen
sample size grows, the two
If
numbers become
increases-
closer together
sample size?
and closer to the sample size of the population.
As the margin of error gets smaller and narrower, the sample size gets bigger. Or as the sample size gets bigger, the margin of error gets smaller, so it gets narrower.
Yeah, it decreases.
It
Yeah,
decreases,
so yeah, it would decrease.
right?
That's what I think.
But I think,
Is that what you said initially, Alicia? Because I was
yeah,
like,
it is.
it just comes through my brain like all the other today. I don't know.
Yeah, it decreases.
Don't fall off the bed. Come back. No. Okay. So number 10 is
So
that what we're
Erin.
on now?
Yep, you're 10.
Okay, what would happen to the width of a confidence interval if Gina changed it to a 99% confidence interval? Let's
Okay,
From a
see.
95?
She's
Would it get bigger?
It would
I think it would
increase.
it would get bigger, wouldn't it?
It would increase.
Yeah, because
Because
in
when
our
you
in
go
our
smaller, it
Huh?
decreased.
yeah, because in our preparation assignment it got smaller when we went from 95 to 90, so
Yeah,
I think it would get bigger.
I think it would too.
Mm-hmm.
Okay.
All right, Kelsey.
Okay, Bright Bulb Light Company is planning a study to assess the average life expectancy of their light bulb. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? So,
Oh, yeah, it's that last one.
yeah,
Oh yeah, we gotta solve for n.
We're solving for n.
yeah,
Okay.
1 point.
Didn't like this one.
I don't like this one either.
Yeah. No way.
None of them. Yeah. N equals
Standard deviation.
Z. What's the Z score?
Standard.
For
Deviation.
90, what percent? 95?
14. We're on number 11.
It's 1.96, I think.
Yeah, 1.96.
Yeah, yeah.
1.96
Sample size. Oh, we don't know what the sample
times standard deviation of 400,
Okay, so that's then.
all divided by M.
Okay.
M is 50, right?
Yeah.
Raised to the second. What?
So I got 246 total.
No, you're not going to
I
get
hope I
enough.
did it right.
Honey, I will as soon as I'm done. Sorry, my daughter came in.
No, you're good.
Okay, what's the
0.96 times 400
in this one?
was that. Divided by 50 was that. Raised to the square.
This will help me to get in the right.
So I got 245.862.
Yeah, so we rounded up to the nearest whole number.
So it's 246.
Yeah, that's what I got too.
246.
Yep.
Is that what you guys got? 246?
Awesome.
Okay,
Okay. Yep.
I'm struggling. I got on the wrong question, so I'm not with you guys at all. Okay. So what we have a standard deviation of 400, right?
Yes.
Mm-hmm.
Divided by the margin of error is 50, right?
Yes.
Okay, I'm back with the living here. Sorry.
But you multiply the 400 times the 1.96.
First.
Yep.
Yeah. And then you divide it by the 50. And then you raise it to the square.
68.
Divided by.
Bye.
I always like it when the numbers are in a row like that. 2, 4, 6.
I agree.
Yeah.
It just makes me
So
want
you
to keep
guys,
counting.
are you guys on number 12 yet then? Or?
What did you guys get?
2, 4, 6.
Yeah, 246.
We're rounding it to a whole number, huh?
Yep.
I
Because
got
you can't
that.
have a part of a person. You have to have a whole person.
2, 4, 6. I got that. Back with the living here. Totally spaced that one. Okay.
The next one looks fun.
The mean salary
know,
of
right?
actuaries is $100,000. So
That'd
I'm
be
going to
nice.
make some notes as we go along. I'm going to try to keep this all straight in my brain this time. So
Okay.
the mean salary is $100,000.
Oh,
And
I'd even take the standard deviation.
Yeah.
is
Yeah.
1,730. I'd like to earn that. Yeah. And you're interested to know if the mean salary for women actuaries is different from the population mean. So it's not equal to, okay, and that's down below. H is not equal to 100,000. So they give us our null and alternative hypotheses here.
Yeah.
Down below.
And our, what is that? A? What is?
But you're not sure if it's higher or lower. You set up the hypotheses with a level of significance. Alpha is 0.05.
Yeah.
You collect a simple random sample, N, of 36 women's salaries, and find that your X bar, your sample mean, right,
Yeah.
is 111,000.
Ah. 3 questions. Okay.
Question 12. What is the lower limit of this 95% confidence interval.
Wait.
So we're
Remind
just
me what
plugging
formula
in
we
some
use.
numbers, right?
The big one.
Oh, the lower. Yes, big one.
Yep.
So you would just put in so what would you put in for x then? Would you put in
11, the one, because it
Yeah.
says the sample mean is
The 111,000.
111,000,
Okay.
and the standard deviation is 36.
Are big numbers. 1,000.
Sample
deviation
size
is 36,730. And then
Minus
Woohoo!
that
Those are
is
big numbers.
minus 36.
1.96, right?
Yep.
Yeah, the z-score is 1.96.
Divided by, oh, what is it? The mean, just 36,730. 6 divided by the square root of 36. Whew. Okay. Sorry, some big numbers, guys.
Yeah.
Yeah.
Is that 95%? That's 1.96 for the z-score, right?
Yeah.
Yeah, 1.96.
Oh, for a minute, I thought I did it wrong.
No.
Think
Has
I'm
anybody
okay.
gotten yet?
2. Nope.
I'm-
What?
6.
Has anybody what?
I was just wondering if anybody got it yet.
Yeah, I'm there.
No, not yet.
Okay.
I got it, Erin.
Sorry, I'm slow.
I just
Did
plugged
either of
in,
you guys
though.
get let's see 99,002?
Yes.
Okay.
That's what I got.
All right, yeah, me too.
Would you enter this with a comma?
7. I don't know.
No, you just do the lower limit, and then the next one's the upper limit.
No, I mean when you're entering it, would you do 99,002 or would you put a comma after the 99?
Oh, no, don't put any commas.
I don't think, yeah.
Okay, what'd you get for it? 99,001.53.
And we round up.
It's 2 because you got to round it to the nearest whole number.
Oh, the whole number.
Yeah, that's
So
what we got.
99002, right?
Yep.
2.
And then the upper level would be what? 122,998.
999, right? Because it's 998.4, so rounding up would be 999, wouldn't it?
No, you don't round up. You just round to the nearest whole number. If it's under 5, you
Oh, I thought you always round up.
not with
Not with this.
confidence interval.
So wait,
then-
122,998.
Didn't we round
That's
it
what we
like
got,
that?
yeah.
Didn't we round it on question 13?
You rounded it up because it had a 0.5. So 5 and above you round up, 4 and under you round.
Oh,
you round-
right. We're taking to whole numbers though, right?
Yeah, we're doing a whole number though.
Yes.
Yeah.
Okay.
Yeah, you're right. I'm just trying to be confused again.
No, you're okay.
Successfully too.
Oh. Okay, there we go. All right, number 14. Ready?
Yep.
There are 3 requirements that need
That's the
to be
weirdest
checked when computing a confidence interval for a mean. They are,
What a weird question.
the whole random sample was, I know, drawn from the population. The mean are the standard deviation. The mean population is normally distributed. It's all of the above.
Yep.
Yeah, it's definitely all the above.
Like you give me the answers and they're the right ones. Like it just
Yeah.
it's trying to reinforce it, I guess.
It's dumb though.
Yeah, that's why I asked that question like twice on the prep work.
I know,
What-
right?
Part one
So we
and
obviously need to know this.
yeah.
I'm submitting. I'm being brave.
Okay.
Hang on. It's not scrolling down. All right. And the verdict, what? Is 100%.
Great.
Yay! Great.
Awesome,
Awesome.
guys.
Well,
Hey, can we talk about our project thing for a minute? Did you guys look at it at all?
nope.
I sent you all an email.
I haven't looked at it yet, but I was going to when I got off.
And we don't have to record that part, right?